Hey guys, today we'll be discussing about the boundary buffer problem. It's also called as the producer consumer problem. So, boundary buffer problem or the producer consumer problem is one of the classical examples of the problems of synchronization. So, now what we would be discussing is more like we'll be discussing can we solve this problem using semaphore? So, basically, now we'll see the problem statement. We see the problem statement goes like we have a buffer, we have a buffer, we have a buffer. So, the buffer basically has n slots. Okay, and there are two processes. The first process would be producer, and the second would be consumer. So what the producer does is it inserts data. It produces data and inserts it into the buffer slots. Whereas what the consumer does is it consumes the data that is given by the producer into the buffer slot. Basically, it removes the data. So it removes the data. These are the two processes that are done in the this problem statement. So basically, which can be solved by using three semaphores. The semaphores are mutex. So mutex is basically a binary semaphore which is used to obtain the mutual exclusion state. So what mutual exclusion means is we are now trying to lock the data so that only one semaphore can access it and only one process can access it. It actually works more like a lock. The second semaphore would be empty. So empty is more like a counting semaphore, whose initial value is the number of slots in the buffer, basically because number of empty slots. So for example, here at the beginning there are n slots and n slots are empty. So value of empty would be n. Whereas at the initial state, full will be number of full slots would be equal to zero. So the value of the counting number full, which keeps account or tracks the number of full slots. So basically, it is zero at the initial. And now let's discuss about the conditions that are to be achieved. So the first condition would be, for example, the buffer slot is full. In case it has every slot has data, and now the producer process is trying to insert the data into it, which cannot be done and cause an error. So this should be avoided. The second thing would be the slot is empty, and now the consumer tries to consume. What it is trying to consume? Already it is empty, so nothing can be consumed. So this is also error. And the third thing would be only one process will be access the data at the time. If both processes are trying to access data at the time, it may cause some deadlock. So this should also be avoided. These are the three cases that we should be done and using these semaphores. Now we'll see how we can solve this problem.
Now let us see how the producer process should work. So basically the producer should wait until the value of empty is greater than 0. So basically let us consider buffer with 4 buffer slots. So initially the value of empty would be 4. So now we check the value of empty is greater than 4. So what we will do is we'll be decrementing the value. The value of empty will become 3 and we'll be locking this position using the mutex. So now the producer would add the data in here, and then the lock would be released by using the signal call, and then now initially the full value would be 0, and using the signal call we'll be incrementing the value, so the full becomes 1. This is how the producer functions. So basically this process repeats where the value of empty would decrease and the value of full would increase. This is how the producer works. So now let us see how a consumer should perform. So basically, your consumer should wait until the value of full is greater than 0. Now let us consider a buffer with 4 slots and all the 4 are full. So basically, the value of full would be 4 and the value of empty would be 0. So now what happens is we have to log the place and then using the notice call, and then we remove the data from it. After this, we would be releasing the lock using the signal call, and then we'll be incrementing empty. So the value of empty will become 1. This process repeats until the value of full becomes 0 and empty would become 4. When this stage reaches, the full would be 0, so the wait function fails and gets out. So this is how the consumer should work. Thank you.